Before the video starts, you can find my worksheet in the description of this video. The worksheet itself contains my notes, past paper questions, and my detailed solutions of each past paper questions. So download it and go through all the questions in there. You also have micro explanations throughout the worksheet so that it can make understanding what's going on a bit easier to understand. So yeah, download the worksheet and let's get started with the video. Okay, so let's dive into the explanation of differentiation. The very basis, the fundamental to understanding how differentiation works is understanding what is a base and an exponent. Basically, if you have 5 raised to the power of 3, 5 is the base and 3, which is the power, is called the exponent. And then, assuming that we have something like 5x squared. 5 is what you would call the coefficient, and x raised to the square, where square is going to be the power 2 is actually going to be the exponent. Exponent, right? So that's the basis, right? Now let's differentiate this as our starting point to understanding how to work through this chapter. So I'm just going to have an equation. Y is equal to 5x raised to the square. Now let's find the dy over dx. How do we do this? Well, differentiation is done by bringing down the exponent and multiplying it with the coefficient, which is 5. So 2 times 5, and then we need to subtract 1 from the exponent. Therefore, the dy over dx is going to be 2 times 5, that's 10, and x, because 2 minus 1 is 1, so x raised to the power of 1. We do not write x raised to the power of 1 is just x. Okay. This is just how you do it, okay? There's nothing more to it. So let's work out some examples down below. Y is equal to x raised to the cube dy over dx is equal to, bring down the exponent. Okay, I do apologize if you could hear my cat in the background. So let's keep moving forward, shall we? Bring down the coefficient, no, the exponent, sorry. Bring down the exponent 3. So 3 times the coefficient of x, which is 1. X, this is what we have, but we don't write the 1, so the coefficient is 1. 3 times the coefficient x, and then we need to subtract 1 from the exponent, so that's going to be 2. Therefore, dy over dx is equal to 3x squared. That is your differentiation of that. Okay, moving on to example 2, something a bit more tricky. This time we have a fraction. Okay, so imagine we have 2 over 5. 2 is what you would call the numerator, and 5 is what you would call the denominator. Okay, so in order to differentiate this, we need to bring up the denominator. So y is equal to, bring that up, and that is going to be x minus 3. Now we can differentiate this. So dy over dx, the same logic applies as before. Bring down the exponent and subtract the exponent by 1. So minus 3x, minus 3 minus 1, that's minus 4. Now, the exponent doesn't like to be negative. It does not like that. It wants to return back to being positive. So dy over dx is equal to minus 3 over x raised to the power of 4. That's your answer. Okay. Moving on to example number 3, something a bit more complex. Y is equal to x raised to the power of 3 plus 5 bracket, everything raised to the power of 4. How do we do this? So first, we are going to consider y raised in the bracket as just x, okay? So y is equal to x raised to the power of 4. Now, dy over dx is equal to, bring down the exponent and subtract it by 1. That's going to be 4 bracket. I'm not going to write, okay, this is a bit complex the way I'm explaining it. Okay, so for this one we have y is equal to bracket x cubed plus 5 close bracket, everything raised to the power of 4. So the way to solve in this is that we will first differentiate this 4, and then after we've brought down the exponent and subtracted it by 1, we will then differentiate whatever is in the bracket, okay? So dy over dx is equal to, bring down the exponent and then subtract it by 1. That's going to be 4x cubed plus 5, and 4 minus 1 is 3. Now, we are going to differentiate whatever is inside the bracket. I'm just going to write it over here. U is equal to x cubed plus 5. Obviously, in exams you won't be doing this, but for sake of explanation, I am going to write it like that. But you will technically be expected to do this in your head. So, yes, u is equal to x cubed plus 5. du over dx is equal to the same thing. Bring down the exponent and subtract it by 1. That's going to be 3x squared. 5 just becomes 0. So, okay, now we have differentiated what's inside the bracket and we need to multiply it to this. So 3x squared dy over dx is equal to 4 times 3. That's going to be 12 x squared x cubed plus 5 raised to the power of 3. There. That's the solution for example number 3. This is supposed to be example number 4. I don't know why I wrote 1. Okay. Everything so far is it follows the same trend of bringing down the exponent and subtracting it by 1. But things start to change a bit when we get into logarithms, ln exponents, and all that. So here's a basic example. Y is equal to ln x plus 1. We need to differentiate this, and there's only one way to differentiate in ln. That would be dy over dx is equal to, simply bring this down and make it, that's going to be 1 over x plus 1. That's it. That's literally all you need to do. But the reason why there's a 1 here is because we still need to differentiate whatever is found inside the bracket. So getting rid of the ln, y is equal to x plus 1. Let me just replace this with u. Differentiating du over dx, that's going to be 1 because x raised to the power of 1, 1. It is this differentiation of what's inside the bracket that ends up coming here. That's it. And then the rest, you just bring it down and make it a denominator. So let us, let us differentiate this. I'm just going to put a spacer or divider here. dy over dx is equal to 3. 3 over 3x plus 2. Again, because we differentiate what's inside the bracket, and then that gets multiplied to the outer differentiation. So let me just do another example. Y is equal to ln 2x squared plus 2. dy over dx is going to be, bring everything down and make it a denominator. So that's going to be 2x squared plus 2. Now differentiate what's inside the bracket. U is equal to 2x squared plus 2 du over dx is equal to 2, bring down the exponent and subtract it by 1. That's going to be 4x, right? Now we need to multiply 4x to the differentiation of ln, which is following the same logic that we did above here, where we first differentiate the outer bracket and then we differentiate inside the bracket. In this case, ln is the outer bracket. So the answer is going to be dy over dx is equal to 4x over 2x squared plus 2. There. That's the solution. Example number what? Number 5. I'm so sorry for screwing this up. Number 5. Oh my god. There. That's a terrible looking 5. My god. Okay, just there. Number 5. Okay, so there's kind of a joke in the mathematics community where people assume that exponentials are like, they can't be destroyed, right? They I suppose you could say, like,
How could you do this? The people of the city relied on you and you deserted them. You left us.
Above you can destroy the ln and convert it into this thing, but when exponentials are involved, they can't be destroyed. So if you had something like y is equal to I don't know, 2x, the differentiation would simply be dy over dx. Differentiate this thing is going to just be 2, and then you just bring it down. 2e, 2x. This thing remains the same, it remains constant. So let's differentiate this. dy over dx. Differentiate what's above. So u is equal to 3x minus 3. du over dx is equal to, this is raised to the power of 1, so bring down the exponent, 3, minus the exponent, that's going to be 0, x raised to the 0 is 1. So x0 is equal to 1. So the dy over dx is going to be, du over dx is going to be 3. Therefore, the dy over dx of this is going to be 3 e 3x minus 3. That's it. I know because I explained this thing over here, it kind of makes it look a bit more bulky, but once you start to get a hang of doing this differentiation in your head, it's really straightforward. So let's try one without me doing all of that. Y is equal to e raised to, I don't know, 5x minus 2 dy over dx is equal to, the differentiation of this is going to be 5. So 5 e 5x minus 2. That's your answer. Oh, there. Good. Good. Now, in this chapter, you also have a few other rules, like the chain rule, the product rule, and the quotient rule. I will not be explaining these right now. I'd prefer explaining it to you when I'm working some past paper questions like that. It's much easier to digest what's going on, because if I were just to explain the theory right now, that would make things a bit more complicated. But the product rule, essentially, use this formula for the product rule when you have a formula that's multiplying two different things. So in this case, multiplying an exponent to trigonometry, and then the quotient rule, you use it whenever you see there is some sort of a fraction, so a denominator and a numerator. That's when you use this formula right here. And then the chain rule, this is an interesting one. I technically already did the chain rule, but you did not notice it. So this right here, that was done using the chain rule. See this whole thing over here, that's the chain rule, except I bypassed the equation and did it a bit more, what's the word? A bit more gritty, okay? I did not pass through the equation directly, but the same logic does apply here. You will observe me using this when working the past paper questions, but there is two theories that you need to know. Theories to know: stationary points and maximum stationary points. I will brush through this because you will better understand it when I start working the past paper questions. A stationary point essentially occurs when dy over dx is equal to 0, basically at the top of a curve. And then we have a maximum stationary point. These allow us to understand the nature of a curve or a graph. So if a graph is at a maximum, the d square y over dx square is going to be less than 0 when a curve occurs at a maximum point. And when it occurs at a minimum point, the d square y over dx square is going to be greater than 0. So, with that being said, let us start working some past paper questions. Okay, so moving on to the past paper questions, we have October, November 2020. Whenever you see an equation like this, you need to know that the only way to solve this is using the quotient rule. Basically, whenever you have a fraction like that, you need to use this equation. So, how do we do this? We need to first identify our u and our v. Y is equal to e 2x minus 3 over x squared plus 1. This is going to be our u, and this is going to be our v. So u is equal to e raised to the 2x minus 3. V is equal to x squared plus 1. Now we need to differentiate u and v. So du over dx is equal to 2e raised to the 2x minus 3. dv over dx is equal to 2x. That's it. Now that we've found out our u, v, du over dx and dv over dx, we can now plug these things into this equation. So, what I want you to do is rewrite the equation dy over dx is equal to v du over dx minus u dv over dx over v square. Right, now let's just plug them in. Is equal to x square plus 1 du over dx, which is this. Oh shit, I'm writing it in such minus our u. So okay. So now we can distribute the brackets, which is going to give us, let's say, we can't do anything over here, but we can multiply 2x to the exponent here. So x squared plus 1 2e raised to the 2x minus 3 minus 2x e 2x minus 3. X squared plus 1. That is your dy over dx. Now, hence, given that y is increasing at a rate of 2 units per second, find the exact rate of change of x when x is equal to 2. This, whenever you say question that involves these specific words such as rate, change in per unit time or seconds, and then you need to find the change of x. these questions are always the chain rule. So let's understand how to do it. So whenever you find a question like this, where they're telling you that something such as y is increasing or decreasing at a rate of 2 units per second. Basically, something is increasing or decreasing, and then you also need to find the rate of change of another thing, in this case, x. That is always, in most cases, going to be the chain rule. That. So we're going to use this equation here. The question that we did below was the quotient rule. So now we're going to do the chain rule. The question is telling us that y is increasing at a rate of 2 units per second. So dy over dt, dt, t being time. So dy over dt is equal to 2. They want us to find the rate of change of x. So dx over dt. This is what they want us to find. And dy over dx is currently unknown. Oh yes, by the way. They want us to find the rate of change of x when x is equal to 2. So x is equal to 2. Let's write our chain rule equation. Dy over dx is equal to dy over dt times dx over, dt over dx. I want you to notice something here. Dt can cancel dt, and when we multiply this with this, we end up getting dy over dx. So that's why this equation makes sense. Right, so let's find the gradient. We already have the equation for the gradient, which is dy over dx that we calculated over here. It wants us to find this when x is equal to 2. So let's just copy paste the equation that we got. Oh shit. There. Let's calculate the gradient when x is equal to 2. I just want to check if this is recording. Yes, it is. Good. So let's substitute all the x with 2. I'm just going to do it directly in this thing here. So 2. Did I just miss something? Okay, yeah, I missed the exponent. 2x plus 3. 2x plus 3, that's going to be x substituted by 2 minus 3. Two plus 1, okay, and then when we compute this thing, we are going to get 10e minus 4e over 25. This is our gradient when x is equal to 2. Okay. Oh, actually, I can just simplify it even more. 10 minus 4, that's 6e. 6e. That's even more simplified. Okay, so now what we have dy over dx is equal to 6 over 25e. We have dy over dt, which is 2, and we're supposed to find the dx over dt, which is unknown. Our equation for the chain rule is dy over dx is equal to dy over dt times dt over dx. Right. In order to make dt over dx become dx over dt, we simply need to send this over here and divide dy over dt by dy over dx. So dx over dt is equal to dy over dt times dx over dy. I want you to pay attention to something. If we cancel dy and dy, suddenly we get dx over dt. So that's how the chain rule works. Okay. Right, so let's just plug in the values of dy over dx, which is this and that. Although keep in mind, we no longer have dy over dx, we have dx over dy, which means this is inverted. So dy over dt, which is 2 times 25 over 6e. And that's going to give us an answer of dx over dt is equal to 25 over 3e. That's your answer. Good. Okay, now moving on to the second question. May, June 2020. We have some equation here. This equation is going to use the product rule. Product means multiplication. Whenever you have something like this, a fraction, you're going to use the quotient rule. And whenever you have something that's been multiplied, you are going to use the product rule. So we have been given some equation and we need to show that dy over dx in this form where a, b, c are integers. Okay, we can do that. So a, y is equal to x squared minus 1 5x plus 2. By the way, we can express square root as x raised to the half, and 1 over square root x can be expressed as x minus half, raised to the power of minus half, sorry. So this is going to be a very important piece of information. This is going to be a very important piece of information for solving this question. Y is equal to x squared minus 1, 5x plus 2, raised to the half. We now need to identify our v and u. This right here is going to be our v, and this is going to be our u. although it doesn't really matter which one you make your v and u when dealing with the product rule. Okay, so let's just write them down here. V is equal to x squared minus 1, u is equal to 5x plus 2 half dv over dx, that's going to be 2x. Yep, and du over dx, that's going to be... Okay, I'm not going to solve it stepwise like I did above in the explanation. I'm going to solve it directly because it's just going to be the same concept. So that's going to be 5 over 2. Right, so du over dx is going to be 5x plus 2, and I'm going to subtract 1 from the half, which is going to be minus half. Okay, so now we've found out our v, we can now rewrite the equation for the product rule, which is dy over dx is equal to v du over dx plus u dv over dx. Now, we simply need to plug in everything into our equation. Let's do that. So, so our v is going to be x squared plus 1 bracket 5 over 2 5x plus 2 minus half, okay, plus dv over dx, okay, let's say 5x plus 2, there. Now we simply need to distribute the brackets, which is going to give us, let's say we can rewrite this thing as minus 5 over 2 there plus 2x plus 2 there. Okay. So, as mentioned before at the start video, exponents dislike to be negative. So, let's make it a denominator. Is equal to 5 over 2, let's see, okay, so now, if we want to get rid of 5x plus 2 raised to the power of half, we need to multiply this by 5x plus 2 raised to the power of half over 5x plus 2 raised to the power of half. So let's just do that. Is equal to 5. Okay, so now that we have this and this as common, we can simply unify them. So 5x squared minus 1 plus plus, that's an ugly looking plus. 5x plus 2 raised to the half. 2, 5x plus 2 raised to the half. Over, oh my god, such a horrible line. Over there. 2, 5x plus 2. Now, you might be wondering, why did I do this? Well, when I cancel this out, this is going to cancel out. But I need to multiply it to this in order to be able to cancel it out, which then brings us back to this. So that's why. Okay, we can get 5 minus 1 plus 4x. Since these two are similar, we can simply multiply them together. So an exponent so imagine we have 3 square plus, sorry, multiplied by 4 by 3 power 6. You are not going to get 3 raised to the power of 12. That's wrong. What you're going to get is 3 raised to 8, because we add the exponents, which is what's happening here. Half plus half is equal to 1. So 5x plus 2 raised to the power of 1, because we are multiplying these two. That's the reason why. Okay. 2, 5x plus 2. Okay. So now we can expand the brackets by multiplying these inside, and we're going to get 5x squared minus 5 plus 20x squared plus 8x over 2 5x plus 2 half. That's going to be 25x squared plus 8x minus 5 over 2 5x plus 2. There. Now a is equal to 25, b is equal to 8, and our c is going to be minus 5. That's how you solve this kind of question. A, b. Find the coordinates of the stationary point of the curve for x is greater than 0. What we're supposed to do is find the stationary points of this curve. We know that SP, or stationary point, occurs when dy over dx is equal to 0. Okay, so let's just rewrite this equation down here. This is going to be our simplified dy over dx. Now let's just equate this equation to 0. 25x squared plus 8x x minus 5 over 2 square root 5x plus 2 is equal to 0. Multiplying this denominator to 0 is going to give us 25x squared plus 8x minus 5 is equal to 0, which is a quadratic equation that we can solve using the equation x is equal to minus b plus minus b squared minus 4ac over 2a. Mitochondria is the powerhouse of the cell. Is equal to, we've already gotten our a, b, and c over here, so just plug that in. So minus 8 plus minus 8 square minus bracket 4 8 minus 5 over 2 25. That's going to give us x is equal to minus 8 plus minus square root 224 over 50. And also, yeah, this is going to give us x1 is equal to 0.31 and x2 is equal to minus 0.63. Now, if you go back to the question, it's going to tell you 4x is greater than 0, which means we can't have a negative value. We are going to reject this one. Therefore, oh my god, why am I so clumsy? Therefore, x is equal to 0.31. That's your answer. Okay, moving on to part C. Determine the nature of the stationary point. To determine the nature of a stationary point, we need to do the differentiation of the differentiation, which is the differentiation of dy over dx, which is going to give us d square y over dx square. But we are not going to do this here because we have this kind of equation, which I'm going to explain in a moment. There. And this equation has a quadratic part to it. So we can simply use that to get our answer. 25x squared plus 8x minus 5 is a quadratic equation. Equation which has a graph. Has a graph that looks like this, so like that, which by the way is going to be a minimum. And if by any chance you haven't learnt what kind of graph the quadratic equations produce, you can feel free to plug in values starting from 0 to perhaps 5 or 10 in some chart like that. This is going to be your x, this is going to be your y. So 0, 1, 2, 3, 4. There. By the way, this is going to be y is equal to. Okay, so you're going to plot the graph here, a rudimentary graph, and it should give you a basic rudimentary form, which will help you gain some understanding on the nature of this graph. But usually, you would need to find the differentiation of the differentiation. The reason why we did not do this here is because this is just 2 points. You're not they don't really expect you to do the product rule all over again. This was more of a pitfall question because they expect you to identify this quadratic equation. Okay, so that should be it for today's video. Just keep in mind that you need to learn the basics, because usually you need to implement the basics into far more complex scenarios, like using the quotient equations and whatever. So good luck and see you in the next video. Thank you for watching, and bye bye.